Elementary Statistics Practice Test number 1, which covers Module 1, Chapters 1 to 3. Here's Chapter 3, Describing, Exploring, and Comparing Data. The following data gives the number of hours that a few employees at the GM factory worked last week. We want to find the mean. So first, pay attention to the fact that we're dealing with a few, and that really refers to the fact that that's a sample. So with that being the case, I like to rank it first. And I want you to pay attention to the fact that we don't need to rank it to find the mean. We don't need to rank data for some calculations, such as finding the mean. However, it's a good practice to do so for those calculations that need ranked data, sorted data. Again, if this question was asking for the mean and mean only, you wouldn't waste your time. But we have other parts. So simply put, get to the habit of using formulas. So in this case, X bar is summation of X over N, which means 14 plus 16, all the way to 42 divided by 18. We have 18 pieces, we divide by. As far as the number of decimals is concerned, if they tell you, you follow it. If they don't, you want to carry as many decimals as possible. In some instances, they want you to carry only one more decimal than what's given. As you can see, there is no decimals here, so you can carry with one decimal, which becomes 26.9 in that case. But it's a good practice to keep it. And if you want to do that, remember the rounding happens after all the calculations, because when you want to calculate other things, you got to keep this with many, many decimals to be on the safe side. The next one is asking for the mode, and there is no mode. Why is that? If you look at the numbers, nothing repeats. Since no number repeats, then we don't have a mode. So because no value repeats, there is no mode. What about the median? It's basically the middle of ranked data. And as you can see, I ranked them in this fashion, so it becomes clear we have 18 pieces. So here's the middle of the data. We need to add them up, divide by 2. So these are the two numbers we're going to add up, divide by 2, becomes 26. Mid-range. First, the definition of a mid-range is the value midway between the max and mean. Therefore, you add them up, you divide by 2. Because of the definition of a mid-range, max and mean divided by 2 is 28. So it is highly effective by outliers. Find the range. Range is defined as maximum minus minimum, high minus low. And because it's in order, clearly 42 minus 40. I hope you realize all of this, with the exception of finding the mean, all of this we couldn't answer without ranking. And that's why we don't take a chance. We rank it right away. It so happened that mid-range and range are equal. This is just by chance. It doesn't happen often. There is no meaning here. This happened by chance. I can't emphasize this enough. The following data gives the number of the hours that a few employees at the GM factory worked. And I want to emphasize that because I want to calculate the variance and standard deviation, and we already know what's X bar. So we are using the sample variance, and this is the reason I have this highlighted in red to make sure we use the formula, because when it comes to a sample, we divide by n minus 1 instead of n. And that's basically what happens mostly in the real world. And you can use any of those formulas, makes no difference. So I want to quickly show you how that works. So if I want to stick with this formula, n, remember n was 18, and then summation of x squared. So the first number was 14 when I ranked it, plus all the way to the last one was 42 squared. That's the summation of x squared. Square each one and add them up. Minus summation of x squared. Add them up from 14 to 42, add them up and then square. That's the meaning of this second part. The denominator is very obvious. You do the math, you end up with almost 75. Now, if you were to use this formula, then remember x bar is 26.9444. Using that formula, either way is fine. The very first number, remember, it was 14. So 14 minus this x bar, square it, plus the next number minus x bar squared, plus all the way the last one was 42, the largest number. I'm talking about the ranked data. 42 minus this number squared over n minus 1. We are here, 18 minus 1. When you do the math, it gives you the same answer. It's 75. So both of them give you the same answer. That's as far as the variance is concerned. As far as the standard deviation, you really don't have to do anything. Just take a root of this number. And you're better off taking the root of this number rather than this, because you don't want to take a chance. And again, carry it with a bunch of decimals. It's only a couple of decimals here. So I hope it's pretty clear as to what we are doing. Find the variance and take the root becomes the standard deviation. We want to find the inner quartile range. So IQR describes the middle 50% of values when ordered from lowest to highest. By definition, it's equal to Q sub 3 minus Q sub 1. Therefore, how do we find that? There are different ways. Here's the fast and easy way. First and foremost, these two, add them up, divide by 2. That becomes Q sub 2, which is also known as the median. Then you do the same thing to the bottom half. The median of the bottom half is Q sub 1. And the median of the top half is Q sub 3. So that's the first thing. So Q sub 2, add these two, divided by 2. That's 26. Now, this part, all of this, remember, we have 18 pieces. So we have 9 pieces all the way from 14 to 25. The middle one is 20. That's Q sub 1. From 27 on, the middle one is 34. And that's Q sub 3. And by definition, we are looking for IQR, which is the difference between Q sub 3 and Q sub 1. That results in 14. IQ scores have a mean of 100 and a standard deviation of 15. We want to find the coefficient of variance. It's important when we deal with statistics, we realize it's all word problems. Therefore, you want to treat it as such and write the given. I hope you realize this is the mean. So that this is the value of mu, because this refers to IQ scores for all. This is a population. So mu, and this is sigma. So that's the first thing we want to do. Write the given. We are interested in finding the coefficient of variance. So what is coefficient of variance? Coefficient of variance is defined as the coefficient of variance, or CV, describes the standard deviation relative to the mean. That's the ratio of the two, and is used to compare standard deviations when the units are different. So in this case, the ratio of basically sigma and mu is the answer. So 15 to 100, which becomes 0.15. However, we represent it as a percentage. So 15 over 100, which is 0.15, becomes 15%. Please understand, times 100%. I can't emphasize this enough. Times 100%. So 15%. Use the range rule of thumb to estimate the minimum and maximum usual IQ scores. According to the range rule of thumb, mu plus minus 2 sigma or x bar plus minus 2s. In other words, start from the mean and you go 2 standard deviations to each side. So you multiply the standard deviation by 2. You add it to mu, you also subtract it. Therefore, we are looking at 100 plus minus 2 times 15, which is 30. So 100 minus 30, 100 plus 30. That would be the range from 70 to 130. That would be the range rule of thumb. And now the Chebyshev's theorem, we want to use to find what is the least percentage of those who will have an IQ score of 70 to 130. By the way, the Chebyshev's theorem is used for any set of data, whereas we have what's called an empirical rule, which is dealing with a bell-shaped, symmetrical curve. With that being the case, Chebyshev's theorem, the proportion of values from any data set that fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1 and represents the number of standard deviations away from them. Now, you really have to find out from 70 to 130, how many standard deviations are we talking about on both sides of mu? Because in the previous one, we found 70 to 130, we already know the answer is 2. But if we didn't, then we would have to look at 70 and 130. Their difference is 60. This corresponds to how many standard deviations? Standard deviation is 15, so it corresponds to 4 of those. You divide the 4 by 2, becomes 2. In other words, I want to make sure we understand how we calculate this. You put the lower number 70 here. You put mu, which happened to be 100 here. And you put the upper value, which is 130 here. If you look at this distance, is 30. Distance must be identical, is 30. How many standard deviations does number 30 represent? You divide this number by sigma, and that gives you 2. That, or the highest number minus the lowest number, which is 60 divided by 15, represents 4 standard deviations. And because you want it on both sides, you have to divide by 2. That's why this is divided by 2. And so now we know k is 2 using this formula 1 minus 1 over 2 squared. Results in 1 minus 1/4 or 3/4, which is 75%, which means at least 75% have an IQ score of 70 to 130. In the case of an empirical rule, again, we need to know how many standard deviations. We already have calculated that. That is 2 standard deviations away. And I want to remind you of the empirical rule. If you start with the mean, you go 1 standard deviation on each side, it covers about 68% of the data. If you start from the mean and you go 2 standard deviations away, it covers about 95%. And if you go 3 standard deviations away on each side, it covers almost everything, 99.7%. Because this is 2 standard deviations away, it covers 95%. That is the empirical rule. Empirical rule. So we have the data. We want to rank it, sort it from small to large, and come up with a box and whisker plot. So first, quickly put them in order, and it helps. To come up with the box plot, you need 5 pieces. You need the minimum, you need the maximum, then you need q sub 1, q sub 2, as well as q sub 3. So here's what's happening if you cut it in half. There are several ways of doing that. I showed you how to find q sub 1, q sub 2, and q sub 3 previously. I want to show you a slightly different method. It ultimately works out the same. And using different technologies, you may end up with slightly a different answer. If, however, the number of data is huge, all of them result in the same thing. If we want to go with the precise method, first you look at n. N is 14. You counted. There are 14 pieces. L is called the locator, k over 100 times n. Remember, Q1 in essence is 0.25, okay, the first quartile. Q sub 2 is 50%, 0.5, and Q sub 3 is 0.75. Therefore, if we want to go with this method, Q sub 1 becomes 7, Q sub 2 becomes 15, Q sub 3 becomes 19 because of the following. If we go with the locator, k over 100, we are looking at Q sub 1, therefore we are looking at 25%. So this really, you don't even have to write it like this. Just think of it as 0.25, and that's what 25 over 100 is. So this is 0.25 for Q sub 1, always. If you multiply by the number of data, whatever the number is, it happened to be 14, it gives you the location. That means we want the 3.5th piece of data. In this case, anytime we come up with a number like that, we must round up. Even if it were 3.1, we would round it up to 4, and therefore we want the fourth one. 1, 2, 3, the fourth one is 7. Median is very straightforward. Just add up the middle two, divide by 2 becomes 50. But Q sub 3, if you go back to the concept here, Q sub 3 means what? This is 0.75, see, 0.75. Multiplied by n, n happened to be 14, gives us 10.5. That means the 11th number. So if you keep on counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, the 11th one is 19. Or you can stick with the method that was explained previously. Now, you draw a number line first, and you put the minimum, maximum, you put those three values, 4, 15, 11. 4, 15, and 11, you make up a box. So take a look at what happens. So those, by the way, give you the 15 and 15, as I said. And if you want to go with the method that was previously discussed, the middle of the bottom half, the middle of the top half, and as you can see, they give you the same result. Now, here's the plot. Here's the minimum value. Here's the maximum value. Here's Q sub 1, Q sub 2, Q sub 3, and you make up a box like this. This is how you come up with a box and whisker plot. Do we have any outliers? As you can see, the meaning of an outlier is very simple. Something which is out there, it is way off. But what does it mean it's way off? As far as math is concerned, we come up with formulas. The formulas are as follows. The value for Q sub 1 minus 1.5 times IQR and Q sub 3 plus 1.5 times IQ sub R are the fences that mark off the reasonable values from the outlier values. Outlier lie outside those. So we have to find the IQR. We have to multiply it by 1.5, subtract it from Q1, add it to Q sub 3. Those are the limits. Anything beyond those is considered outlier. So in other words, in math, we go and stick with formulas and numbers. With that being the case, we already have those values. So Q sub 3 minus Q sub 1 gives us 12. We multiply by 1.5, we end up with 18. Q sub 1 minus 1.5 IQR, that means 7 minus 18 is negative 11. Plus 1.5 IQR, Q sub 3 is 19, plus 18 is 37. Which means anything smaller than negative 11 and anything larger than 37 is considered an outlier. Do we have any outliers? Clearly, number 50 is larger than 37. So as you look at this number, this is the only one, and therefore the answer is yes. As far as extreme outlier, in case you come across it somewhere, instead of 1.5 times IQR, they use 3 times IQR. So Q sub 1 minus 3 times IQR, which is 3 times 12, which is 36, or minus 29. So that's how we come up with 36. 12 was IQR times 3. Now we're going to add this to Q sub 3, anything larger than 55. According to that, we don't have an extreme outlier, just for the sake of argument. Are the data symmetric or skewed? Let's look at a few notes, important notes. Number one, make sure the drawing is to scale. In other words, if you start with some sort of a number line, make sure the numbers that you put in are in scale. For example, you put number 1 to, let's say, 60 very carefully, and then you pick numbers 3, 7, 15, 19, and 50. If it's not to scale, all bets are off. Number two, skewed data show an uneven box plot, in which case the median cuts the box into two unequal pieces. Longer part on the right or above the median indicates data is skewed to the right, positive skew. The mean is larger than the median. That's the meaning of it. Longer part on the left or below the median indicates data is skewed to the left, or negative skew. The mean is less than the median. Finally, sometimes the box may look even or uneven, and even skewed to one side. However, the whiskers, tails on each side of the box may indicate otherwise. Therefore, pay attention to both. So take a look at this case. Here's your Q sub 2. As you can see, this is way longer than this one, and therefore it is skewed to the right, or it's positively skewed. And that's the key that you want to pay attention to. How about this one? We want to do the same thing. First, we cut them in half so we can easily see. We can calculate the median. Add these two numbers, divide by 2. There are different ways to calculate Q sub 1 and Q sub 3. Here's an easier way. I hope you remember when we did the easier way. We cut this into 2 equal halves. The median for the bottom half is Q sub 1. The median for the top half is Q sub 3, as I have shown you before. Therefore, this would be Q sub 1, 79 plus 80 divided by 2. And Q sub 3 would be 87 plus 94 divided by 2. So, before we look at the 5 numbers, I hope it's clear to everybody how we came up with that. So first we cut the whole piece in half, then each half divided into 2 pieces. Now, what is the 5 number summary? Here's your minimum, here's your maximum. And then we have Q sub 1, Q sub 2, Q sub 3. And we can draw this again very carefully, come up with a number line probably from, I don't know, 75 to 105 or 75 to 100, and very carefully put those numbers, mean, max, Q sub 1, Q sub 2, Q sub 3. First, I want to just quickly remind you, if you were to find the outlier or outliers, first you have to find IQR, you multiply it by 1.5. So Q sub 3 minus Q sub 1 is 11. You multiply it by 1.5. You subtract it from Q sub 1. You multiply it by 1.5. You add it to Q sub 3. So those are the fences. You want to see whether you have any outliers or not. As far as the extreme outliers, remember we subtract 3 times IQR from Q sub 1. or we add 3 times that plus q sub 3. Now, this data is almost symmetric. Why is that? Take a look at this q sub 2. If you look at the right side and the left side, they're almost the same. And that's why it is symmetric. What I also want to add is, what if we don't have a data that looks like that, which is even? What if we have an odd? And I want you to pay attention to that because that has come up before. If n is odd, let's say we have the same thing here. Look at the same numbers all the way to 99, and I'm adding some number. It's a make-up example. I want to. It's a made-up example. I want to make sure you realize I'm trying to just change n from even to odd to show you what happens. So the median is obviously the middle of the data, which is 87. This is sorted data. This is 87 done. What about q sub 1? There are really several ways of doing it. The one that I showed you with the locator, there are some cases that they consider the median with the lower half and they consider it with the upper half. There are cases that they drop it in both cases. Most of the time you keep it with both. So in this case, if I'm looking at the bottom half, take a look. I have this number 77 all the way to 87. Now the median for that is 80. If I look at the top half and I keep the median 87, take a look, 87 all the way to 103. I have all of those. The median for that is 94. Now, in this case, Q sub 2 is 87. Q sub 1 is 80, and Q sub 3 is 94. And I want to make sure everybody understands what happens if n is odd. You want to be careful with that. If the mean of a set of data is 23 and 12.6, number 12.6, has a z-score of negative 1.3, then the standard deviation must be. We use the fact that the formula z equals x minus mu over sigma, and you want to solve for sigma. Everything is given, you want to solve for sigma, you can interchange them. So sigma becomes x minus mu over z, and now you replace each one accordingly. So this is the number having a z-score. So this is the value of x. The mean is 23, that's the value of mu. And the z-score is negative 1.3, so sigma is 12.6 minus mu, which is 23, over the z-score of negative 1.3. I assume everybody can do the math. The answer is 8, therefore becomes part D. We want to find the z-score for each student and indicate which one is higher. So one student in the art major received those, and in theater major received those values. And these are the answers A, B, C, D. In order to compare and find out, we have to calculate the z-score for each case. Remember, z is x minus mu over sigma, or x minus x bar over s if it's a sample. Either way is fine. So if we look at the art measure, x minus x bar, x is 46, x bar is 50, divided by s, which is 5, that will result in negative 0.8. We're going to do the same thing for the second one. X is 70, x bar is 75, s is 7, and that results in negative 0.7143. I hope you realize the meaning of it, and that is, when the z-score is 0, the score is equal to the average to the mean. If it's positive, it's better than average, it's above average. If it's negative, it's below average. So both cases happen to be below average in their class in art measure as well as a theater measure. But which one is worse? This is more negative, so this is a better score. Both are negative. This is more negative. This is slightly better. Both of them below the average. If the 5-number summary for a set of data is given, the mean of this set is as follows. I hope you realize we have no idea what the mean is. We don't have enough information to find it for a simple case. How do you find the mean? If it's a sample, is x bar equals summation of x over n. If it's a population, summation of x over capital N. What does it mean? In order to calculate the mean, you need to know each and every one of the values. We don't have it, therefore we don't have enough information to answer. Which of the following is true? The answer is B. Let's see why. Let's just do the description of this concept. D stands for deciles. What are deciles? Measures of location that divide the data into 10 equal parts. P stands for percentiles. Measures of location that divide the data into 100 equal parts. Q stands for quartile. Measures of location that divide the data into 4 equal parts. Therefore, D5 equals P50 equals Q sub 2. The student received the following grades: an A in stats, 4 units, F in physics, 5 units or 5 credits, a B in sociology, 3 units, a B in literature, 2 units, and a D in tennis, 1. Assume A is 4, B is 3, C is 2, and D is worth 1 grade point, with F being 0. We want to find the GPA. And this is important for you because that's how your GPA is calculated. So this is weighted average or weighted mean. When different X data values are assigned different weights, W, we can compute a weighted mean. To find the weighted mean of a variable, multiply each value by its corresponding weight and divide the sum of the products by the sum of the weights. And it gives rise to the following: summation of WX divided by summation of W. And I hope you realize why this is the case, because if you happen to have 1A and 1B, one of them is 3 units, the other one is also 3 units, you get an average of 3.5. But if your A grade is worth 5 units and the B one is worth only 2 units, I hope you see that it's heavier towards A, and that's why we use the weighted mean. So it should be higher than 3.5, and it will be. Therefore, it's a good practice to write the following table. So here's the grades. For example, A in statistics, the weight or the number of units was 4, and A is worth 4 points. The next one was F, and how many units? It was physics, 5 units worth 0. The next one is B in sociology, 3. So B is 3 units worth 3 points also. This one is 3 worth 3 points, but it's only 2 units. That's why you want to be very careful. And finally, D, tennis, only 1 unit. You multiply this column by this column, and you divide by the total number of units, if you will. So we are multiplying this column by this column, that becomes the numerator. Add them up. And the weights or the number of units, you add them up, becomes the denominator, however many units you have. On a normal basis, they carry only 2 decimals. I want you to know that for the GPA. So just make sure you carry enough and follow the question for proper answer. We have this data, and we want to find the value corresponding to the 75th percentile. So first and foremost, we have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data, and we want to rank him. So those two things, we want to rank him. Sort them from the smallest to the largest. N is 8. If you want to go with the locator now it's important to stick with that because we want to find the 75th percentile. So basically what this means is we want to find the location of this number 70. So this number in essence is really 0.75 class, or you can say 75 over 100. What is N? Again, we have counted, we have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So N is 8. Let's do the math. So therefore 75 means 75 over 100 or 0.75. So basically 0.75 times N, that is the 6th place. Now, what statisticians do when it's a whole number, then they go with the next one as well, and they find the median of the two. The 6th number and the 7th number are those two numbers, they add them up, divide by 2. They only do that when it's a whole number. The next one is asking for the 30th percentile. That means 0.3 times N. 0.3 times N. That's the meaning of this formula class. This is whatever they give us. 0.3 times N. N happened to be 8. We get 2.4. And we always round up this number. So this is the location. That means 2.4 number. So we rounded up to the third. And here's the third number, which is 50. We want to find the percentile corresponding to number 44. So the way it works, you find number 44 and see how many people are less than that, and you divide by N. So locate 44, so number of values less than 44. So here's 44. 1, 2, 3, 4, 5 of it. And you divide by N. And this is the location, believe it or not. Now, of course, we're going to change that to a decimal with a bunch of decimals, and we always round it accordingly. So if it's percentage, it becomes 62.5%. We round it up, becomes 63. If it was 0.621, we would say P62. So we round it accordingly. And the final question on this one is using range rule of thumb, estimate the standard deviation. I hope you remember when we did the range rule of thumb, it was mu plus minus 2 sigma. That means 2 standard deviation on each side. That is the range rule of thumb. 2 on each side, that means total of 4 standard deviations. Because of that, according to that, in order to find S, range rule of thumb for estimating a value of standard deviation is to divide the range by 4. Roughly estimate the standard deviation from a collection of known sample data. When the distribution is unimodal and approximately symmetric, we can divide the range by 4. Remember, 2 standard deviations on each side. So with that being the case, you find the R, which is max minus mean, and you divide it by 4. So 72 minus 10 divided by 4, and that gives us 15.5. The following data representing numbers of keyboards assembled for a sample of 25 days in a company. We want to come up with a frequency distribution table with 4 classes. Remember, the idea of 4 classes is to be able to come up with the width by finding the range and dividing it by the number of classes. So the width is a range divided by number of classes, and the largest number is 56, the smallest is 41 divided, and this is the number you come up with. You have to round up. The width happened to become 4 also. You have to round up or you miss some numbers. By the way, you start with somewhere, the lower limit of the first class, starting point is a convenient number less than or equal to the smallest value, such as 41. So you either start with 41 or 40, but it's important to make sure all numbers are covered by the time you're finished. If it's not, you want to be careful as to what you choose as your width. So with that being the case, if this is 41 class, then you add the width of 4 becomes 45, add 4, 49, add 4 is 53. Do you see that? Now, how do you come up with that? Remember, the upper limit minus lower limit plus 1 unit is the width. So if we want to go with that, let me just write the formula: upper limit minus lower limit plus 1. Okay, so we don't have the upper limit. Let's say we don't have this number yet. Minus the lower limit, we said we're going to start with 41 plus 1. This is the width of 4. And that gives you, if you solve, I hope you see if you solve, we get 44 because this is minus 40. So take it to the other side, becomes 44. That's how you arrive at that. So with that being the case, you end up with the following: 44, add 4, add 4, add 4, you have all of it. Now, how do you come up with the frequency? You can tally it, or if it makes it easier, you can rank it and then come up with the frequency. So for example, 45, you would tally and you put 1 here. 52, you would tally and you put 1 here, and you keep up until you finish it off. So what I've done, if you rank it, it makes it a tad easier. So for example, if you look at 41 through 44, we are here. Just to look at the first one, 41 to 44. We have 1, 2, 3, 4, 5. So the number in front of that would be 5. You do the rest of it, and you have those. So there are two ways: either tally or do it in this fashion. So as far as ranking is concerned, perhaps you want to rank it even right away, so it helps you see the smallest number, the largest number that we used here, and how we arrive at the width, and so on and so forth. Now that we have that, so we are looking at the same thing. We want to find the mean. Remember how we find the mean. To find the mean, x bar is summation of x over n. Add up every number, divide by n. And we do have it. So the first number was 45 plus 52, all the way the last one was 42. Divided by a sample of 25, we end up with the mean, 48.48. So that's how we arrive at the mean. Now, using the frequency distribution, how do we find them? Well, if we don't have the data and we have the table, how do we come up with the mean? We can't come up with the exact mean, but we can estimate it as follows. We have the frequencies, we have the classes. Because we don't know what each value is, we estimate. We say we don't know. In this case, for example, all of them could be 41, all of them could be 44, or somewhere in between. So how do you estimate that? The conservative estimate is to assume all of them are equal to the midpoint. So you find the midpoint and you multiply each one by the midpoint, the frequency by the midpoint for each class, and then you divide by the size, which is 25. So here's the formula. F x bar is the summation of f times x sub m over n, where x sub m is the midpoint of each class. For example, this would be 41 plus 44 divided by 2, which gives you 42.5, and then the rest of them add the width of 4. So midpoint, lower limit plus upper limit divided by 2. So 41 plus 44 divided by 2 is 42.5. And then since the width is 4, just keep on adding 4. Now add, so multiply these two numbers. In other words, this column by this column, and divide by the total size n. Let's do that. So 5 times 42.5, 8 times 46.5, 8 times 50.5, 4 times 54.5, divided by total of 25. And as you can see, are the two means reasonably close? Take a look. 48.48 versus 48.26. That's extremely close.